So this is finally the last geometric sequence question. I know I've had a lot of them, but there are just loads of different ways they can ask questions about these sequences. So it's not even that we've covered every single question possible, because there's an infinite amount of questions possible. But if you've watched all these videos and you understand all the different problems, you should be able to use those skills and do any question they ask at all in the Leaving Cert. So anyway, we'll jump ahead with this last one. We have a sequence here, 81, 27, 9, and then it goes a few more, and we get the last one is going to be 1 over 27. So it asks us how many terms are in the geometric sequence. Okay, so if it's a geometric sequence, then we know there's a common ratio between each one, that it gets multiplied by a certain number each time. So to find out what that common ratio is, we're going to do t of n divided by t of n minus 1. So that's always what we're going to do, and that should be equal to our common ratio. Let's write that, common ratio. Okay, so t of n, we'll just pick the second one, and we'll divide it by t of n minus 1, the first one. So I'm going to say t of 2 divided by t of 1 is going to be 27 over 81, and that's going to be 1 over 3 if you pop that into your calculator. And we'll just check that by saying t of 3 over t of 2 as well, just to make sure that it's constant, that it doesn't change. So then 9 over 27, because 9 is the third term, 27 is the second term, and again that's going to give us 1 over 3. Grand. So or is equal to 1 over 3 then. So if it's a geometric sequence, remember what the first term is. Well, actually, I'll just write it out here. Geometric sequence is going to be given by t of n is equal to a or to the power of n minus 1. So we need to find what the a is as well, which is going to be the first term, which is easy enough to read. So it's going to be that a is equal to 81. Perfect. So just if you haven't seen a geometric sequence like this, they can or can be less than 1 as well. So if it's or is less than 1 in this case, then it's just going to decrease. It's a decreasing geometric sequence, but that doesn't change it at all. Just most of the other questions we've looked at have had increasing ones. This is still perfectly fine. It's just going to decrease each time. So just if you haven't seen one of those before. So now we need to find out how many terms are in the sequence. Okay, so we know, for example, that this is t of 1, this is t of 2, this is, well, that's a weird 2, this is t of 3, ... and this is, we're going to call this t of n, and we want to find out what n is, what number it is. So what we're going to say is, and also remember, I'm just going to write t of n out here. T of n is going to be 81 multiplied by 1 over 3 to the power of n minus 1. So that's a or to the power of n minus 1. So we're going to let this 81 over multiplied by 1 over 3 to the power of n minus 1 equal to 1 over 27, and we're going to solve it for n. So we've done this once or twice now, so hopefully you guys are familiar with it. So we're going to say t of n is equal to 81 multiplied by 1 over 3 to the power of n minus 1, and let that equal to 1 over 27, which is our last term. And then we're going to need to solve this for n, and then we can find out what number term it is. Yeah? So there's going to be a little bit of algebra in this. So I'll just write this out again first. 81 multiplied by 1 over 3 n to power, or n minus 1, 1 over 27. So the first thing I'm going to do is I'm going to multiply both sides by 1 over 81. So if I go, I'm actually just going to do it here. I'm going to say 1 over 81 and then 1 over 81 and multiply it in here. Okay, so I'm going to stick that in. So then what's going to happen here is we're going to be left with 1 over 3 n to the minus 1, because the 1 over 81 will cancel with the 81 on the top. And here we're going to get 1 over 27 multiplied by 81, which is going to be a fine big number. So the next steps, I'm going to do two things at the same time. On the left hand side, if you remember the rules of indices, this n minus 1 is going to multiply, it's going to be like this, sorry, it's going to be n minus 1 and 3 to the power of n minus 1. So that's one of the rules of indices, that if it's a fraction, then it's just the power of each number in the fraction, so the power of the top and the power of the bottom. So in this case the power is n minus 1, so it's 1 to the power of n minus 1 divided by 3 to the power of n minus 1. That's going to be equal to 1 over, and that big number is going to be 2187. 2187, which is kind of confusing because it's the same numbers as that one there, just moved around. But anyway, okay, so something about this here, so I'm just going to circle that. Anything or 1 to the power of anything is going to be equal to 1. So if you try 1 to the power of 1,000 in your calculator, you'll get 1. If you try 1 to the power of a half, you get 1. 1 to the power of minus 1, you'll get 1. So no matter what it is, this is going to be equal to 1. So then we're going to have, I'm just going to write that over to the side, it's going to be 1 divided by 3 to the power of n minus 1 is equal to 1 over 2187. And what we can do here is we can just get rid of the 1 over, so that means it's going to be 3 to the power of n minus 1 is equal to 2187. So we just kind of got rid of the 1 over there. So the algebra here is a little bit tricky. It's actually probably the trickiest bit about the question rather than the sequence bit itself. So next we're going to have to get this n to the power of n minus 1 down. So how are we going to do that? Is we're going to use logs. Okay, so remember, if you ever want to get a power down, you have to use logs. So we're going to take log 3 of both sides. So what we're going to have is we're going to have log base 3 to the power of n minus 1 is equal to log base 3 of 2187. So again, with the log, you can take this power and multiply it by the front. So you can go n minus 1 multiplied by log 3 base 3, and that's still going to be equal to log base 3 2187. Scroll down a little bit more. I'll go green. So log 3 base 3 is just going to be 1. Okay, so that's then it's just going to be n minus 1 is equal to this number here, log 3 2187. So n is equal to log base 3 of 2187 plus 1. So just move the 1 over the other side. So I'm actually just going to skip over into this box here. Sorry for hopping around a bit. And our final answer then is going to be that n is equal to 8. So if you want, you can, yeah, that's just in the calculator, unless you can do that in your head. So n is equal to 8. And what does that mean? It means there are 8 terms in the sequence. 8 terms in sequence. And there's our question done. So I'll have a quick look at that again, just a brief summary. Geometric sequence, here's our sequence here and how many terms are in the sequence. So first we check for the common ratio, t of n divided by t of n minus 1. So we find that's equal to 1/3, and a is equal to 81. So then we know 1 over 27 is t of n, or it's the last term in the sequence. So if we let the general form, so 81 multiplied by 1 over 3 to the power of n minus 1, if we let that equal 1 over 27, and then we use a bit of algebra and a bit of logs to solve this for n, we can find out what the last term is, or what 1 over 27, which term it is. So hopefully that helped. That's our last question on geometric sequences, and now we're going to move on to geometric series. We still have a few videos to go left in this topic. Hopefully you enjoy them, and if you do enjoy them, like and subscribe. We'll see you next time.